The next position in the toolbar is shared by the Edge Slide and Vertex Slide tools. In this video, we'll look at the Edge Slide tool, leaving Vertex Slide to the next video. The Edge Slide tool in Blender is a powerful feature used in the modeling process to slide one or more edges along the surface of a mesh. This allows for precise adjustments and refinements of the mesh topology. To demonstrate, we'll start with a plane and adjust its shape slightly, then use the knife tool to add a new edge within the plane's area. With the new edge selected, choosing the Edge Slide tool from the toolbar creates a yellowhead pin gizmo on the selected edge. Dragging on the pin slides the edge, keeping it within the constraints of the surrounding area. The two other edges at the ends of the edge being moved act like rails, along which the moving edge slides. Notice how it changes its angle as it moves towards other edges. It is also impossible to move the edge outside the existing area. After performing the slide, we can adjust the characteristics of the slide in the last op panel. Factor adjusts the position of the edge. A value of 0 places the edge in its starting position. -1 places the edge over one existing edge, while +1 places it over the opposite existing edge. This value represents a percentage of the allowed movement along the rail edges. For example, let's assume this edge is 1 meter long and this one is 2 meters long. If we set factor to 0.5, the edge we are sliding will move 50 centimeters along the first edge and 1 meter along the second. Even, when selected, adjusts the alignment of the edge so that it matches the shape of one of the existing edges, and flip makes it match with the opposite existing edge. Clamp, which is selected by default, stops us from sliding the edge past the existing edges. If we switch this option off, that restriction disappears, but we'll probably end up with an invalid mesh. Mirror editing and correct UVs can be ignored and will be discussed in later videos. In the top left area of the 3D viewport, the factor value is displayed while we are dragging the selected edge. In the status bar, several other keyboard options are displayed. These are only available during the drag process. Shift tab is the first one listed, and this toggles snapping. The new snapping setting will remain active even after the edge slide operation has been completed. Exactly what snapping we are activating depends on the current settings in the snapping panel. By default, this will be increment, creating movement in discrete steps. Control is the next option listed. This again toggles snapping, inverting its current setting. But this time, the effect only lasts until the end of the edge slide operation. After pressing Control, we have the option to press the B key to select part of the sliding edge, and then snap this to some other element. Actually, this is only useful in more complex situations than we see here in our simple model, and we'll return to it in a later video. But you can get the general idea of how this snapping technique works in video 49, the PolyBuild tool. G allows us to move the selected edge in any direction. Using this option, we can modify the shape of the surrounding faces. R rotates the selected edge about its midpoint. S scales the selected edge. Shift slows down the movement, giving us greater control over the positioning of the edge. C allows us to slide the edge past its usual limits, but unlike unchecking the clamp option, this displays a set of yellow tram lines by extending the existing edges. The sliding edge must move along these lines when dragged. Pressing Alt or C for a second time will remove the tram lines and return the sliding edge to within its original space. E toggles the Even option, making the sliding edge align to the closest end edge. After pressing E F appears in the status bar. As expected, pressing F will align the sliding edge with the opposite end edge. Pressing G twice offers a keyboard shortcut to the edge slide operation, but using this approach, no gizmo will appear. When we are working with a more complex mesh where we want to use the edge slide tool on several edges at the same time, the fact that edge moves are determined by the length of the rails they move along can sometimes lead to results that we might not be expecting. For example, in the mesh shown here, we want to slide the selected edge loop down so that its edges remain aligned. But when we use the edge slide tool, some edges move less than others. Every edge has moved by the same percentage along its rails, but these rails differ in length, so the actual distances moved vary. The simplest way to correct this problem, and to ensure that all the edges of the loop remain aligned, is to use the key combination S, Z, 0, which scales the selection by 0 in the Z direction, that being the direction in which the edges have previously been moved. You may remember from previous videos that scaling by 0 in a specified direction always aligns the selected elements,